Okay, hi student. Okay, so it's the same thing. Good morning, everyone. For science 2 and also the for science 3 student. Okay, can you listen me and also can you see me or not? Okay, hi, morning. Okay, hello. Okay, can reply me? Can you see me? Morning. Okay, so today you need to prepare your calculation. So you see the title today, I want to discuss about the formative practice. That means all the chapter 2, we under 2.3, is it? So 2.1, 2.2, and 2.3, we need to do the discussion. Okay, so from here, please prepare the calculator and also the exercise you do already. So you go and check your answer. Okay, so we go to start. Okay, we just only got 20 students is watching now. Okay, so from here, okay, we just got 1 hour. I think the time is not enough. So I need to start now. Okay, let's go to the question. Okay, this one is formative, the practice 2.1. So I will discuss the all question about the formative practice. So the student, you can check it, the answer. Okay, let's see the first question. Okay, the first question they ask about the meanings. Okay, you need to explain the difference between the distance and displacement, speed, and also velocity. So we know the difference about the distance and displacement sure from the definition. The definition just talking about the total path travel. That one is a distance. Okay, displacement we're talking about the starting point until the final point. That means the shortcut. That one we call displacement. Okay, another difference should be the distance is a scalar quantities. Okay, remember the scalar quantities means we just measure about the magnitude. So we don't care about the direction. But the displacement, both you also need to mention. That one is a different. So the displacement should be the vector quantities. Then how about the speed and velocity? Also the same definition difference. After that, the scalar and vector also is a different. So now from here, I show you the answer in table form. Okay, so this one is the differences. Okay, first one we mentioned about the distance definition, total path length travel. Then the type of the quantity should be the scalar. How about the displacement? Displacement is a distance between the two places that measure along the shortest path in a specific direction. Okay, you must add shorter path. You must add about the specific direction. Okay, then this one should be the vector quantities. Okay, how about the speed? Speed is a rate of change of the distance. Then this one is a scalar. Then the velocity should be the rate of change of the displacement. Then this one is a vector quantities. I think this one no problem because all is from your textbook already. Okay, then we go to the next part. Okay, the next part should be the calculation. Okay, we see the question. A car moving along the straight road at the velocity 30. Okay, this one should be the initial. Can reduce the velocity at constant rate until stop. So the keyword is stop. Final velocity should be 0. Okay, after 5 seconds. Now the question they want to find acceleration. So important when starting we need to jot down all the info first. Okay, let's see the info. Okay, U equal 30, V equals 0, T equal 5 seconds. The acceleration we don't know. So the whole yellow bar here totally never mentions displacement. Okay, no displacement. Now we need to think about what equation we need to use. Okay, no displacement. So I want the student give me the equation. Okay, so from here, all the students you are watching now, please give me the equation for this question I need to apply. Okay, I want to find acceleration. But the question they never mention about the displacement. So which one equation you need to apply here? Okay, we'll find out how many students can be answered it. Okay, Equation 1, 2, 3, 4. Okay, you just show me which one equation we need to use. Yeah, cool. They give me the answer. We're using the first one. Okay, v minus u over t z. That one is the formula to find the acceleration. Okay, so we just apply this formula. Okay, a equal v minus u over t. Okay, so from here we go and straightforward apply lah. All the thing you just put in. Okay, so 0 is a v, then the 30 is the initial velocity, then over the t. So what is your final answer? Okay, what is the final answer? Your final answer, sure, you need to put a negative. After put negative, that means you need to explain. Actually, why I get the answer should be negative. Okay, so we just wait the student give me the final answer for the acceleration. Okay, remember the unit also must be correct. Okay, -6. Dylan, how come you get -5? 30 over 5. Okay, maybe you wrong typing. Okay, so we get the answer. Okay, with unit. So the answer should be -6 ms -2. Okay, yeah, correct. Okay, then we got -6 ms -2 cannot just ms must -2 because this one is the acceleration. Okay, so from here, after show the answer, we need to explain because you get negative. Okay, you get negative, the answer sure you need to do the explanation. Okay, this one explanation for the negative means the object slow down. Is it the object is slow down? So normally the object slow down, how we go to explain? Okay, we explain like this. The car move in opposite direction of the motion of moving car. Okay, the moving car always go to the right. When you press about the brake, means you are opposite direction of the motion. Okay, you want to slow down the car. So that means the direction become opposite already. You want to make the car become slow down, means you move another direction. So from here they say direction of motion, not direction of the car. It's a direction of motion of the moving car. Okay, you must add the word of motion. Okay, after that, the car is decelerate. Okay, slow down means decelerate. So this one is an explanation when you get the answer is negative. Okay, then we go through to the second one. Okay, the second one is Aina, they ride a small personal transporter at the Badana Botanical Gardens. Okay, now the transporter that accelerate uniform from the velocity 1. Okay, starting with the velocity 1 to velocity 5. So that means initial and final, the question provided. And the time also provided, there's a zero point 0.5 minute Z. So 0.5 minute later, you need to convert become second. Okay, these are not SI unit. Calculate the displacement. Okay, the question they need S displacement. Okay, again, we show the info. U is a 1, V is a 5. Time taken is 0.5 minutes. The question they want to find displacement. So from here, they totally never mention acceleration. Okay, which one equation is totally no acceleration? So now also I need the student give me the response. Which one is no acceleration? Okay, we're going to check which one is no acceleration equation. Okay, average multiply the time. Okay, what means of average multiply average velocity multiply the time? Okay, you want to find the displacement? Yes, that's correct. Okay, but you need to do the average important. Okay, because you take the divide by 2. Okay, u plus v divided by 2. So that should be the second equation. So from here you can write in word. Okay, this one is the word, the word, the handwriting to explain the formula. Okay, suppose the formula is this one. Okay, Deepika show me the formula already. Half u plus v multiplied with the t. Okay, so from here we go to show. Okay, this one is S equal V plus U over 2. Then after that, multiply with the T, is it? Okay, so now we go to answer it. Apply all the thing you go in. Okay, so from here we get 1 plus 5. Okay, over 2. Okay, multiply with the time. Okay, you must very be careful the time, yeah, because sometimes they want to trick you. Okay, when they just treat you, that means your answer wrong already. So this one should be the minutes. 0.5 must multiply with 60. Okay, so what is the final answer? Okay, the student, please help me to calculate. Then you show me what is the final answer. Where what is the displacement? Okay, for this one, transporter. Okay, we just go wait the student go press the calculator and also in the type. Remember the unit. Okay, unit you can refer the question. If they're using meter, then you meter. If they're using cm, then you're using cm. Okay, so from here, can we see any student can answer? Okay. The question they asked about the displacement, cool. Not about the second, not the time. Some got 75, some got 76. What's the difference? Okay, Deepika says 75. After that, we see the alpha. They give me the answer is a 76. Okay, so from here, we go and see which one should be the correct one. Okay, so we're going to show the calculation. The answer should be 90, but who you give me the unit wrong, not S. Okay, the unit should be meter. Okay, the unit should be meter. How come you get 75? 75, what happened? You never change about the unit. Okay, have you changed the unit? You must change the unit. Yeah, 90 meter. Okay, this one is exactly the answer for the displacement. Okay, so we go through to the next question. Okay, the next question is how do you go to determine the velocity from the graph of the displacement against the time? Okay, you tell me how you find. I want to find velocity, but now the graph is a displacement against the time. So what you want to find? Okay, how you go to find? You just mention only this one, no calculation. So you just tell me how you go to find the velocity from the ST graph. Okay, any response? I think this one no problem. If you understand about the motion graph, then you know how to find the gradient, how to find the velocity from what graph. Okay, depends the graph what you want to find. Okay, the answer is answer for A. Okay, velocity from the ST graph. How to find it? Okay, how to find it the ST graph? Find the velocity. Okay, anybody? Yeah, Deepika, there's a gradient of the graph. That's correct. Okay, Divesh also correct. Okay, we find the gradient, easy only. So we just write a velocity that's equal to the gradient of the ST graph. Okay, finish. Then we go to B. B is the same thing. They ask about acceleration you want to find, but from the VT graph. Okay, again, they want to find the acceleration, but from the VT graph. So again, we find a gradient of the VT graph. Still gradient. Okay, then we go to the last one. The last one, they're asking about displacement. Okay, displacement from the VT graph. Okay, I want to find the displacement, but from the VT graph. This one is no more gradient. Okay, anybody can answer me about this one? Yeah, so fast, Divesh. Okay, there's an area under the gradient. Why come area under the gradient? Area under the graph. Yeah, not gradient. It's area under the graph. Okay, that means you draw the line, that one is below. Okay, below that one, the area, we call the area under the graph. Okay, let's see the answer. So C should be displacement. There's an area under graph. of the VT graph. Okay, so this one is the answer for the A. Then we continue to the next part. Okay, the next part should be the graph. Okay, they want us about the motion. You need to describe the motion for the object from the O until the D. So you need to explain every part. Okay, we separate part by part to explain. Okay, OA, excuse me, motion. When it's just talking motion, we cannot say slow, we cannot say fast. We either say about the velocity or either you say about the acceleration. Okay, now OA. Actually, OA is what meaning? Okay, what's a motion for the OA? Anybody can answer it? Okay, OA. OA, how about the motion? Okay, OA motion is, okay, anybody can give me velocity increases. Yes, correct. You can say velocity increase. If I still want to answer by acceleration, how to answer it? Yes, we just acceleration constant. Okay, perfect answer. Acceleration constant. So from here we just give the simple only either one. So I just show either one correct answer. Object accelerate. Okay, object is acceleration. Okay, the object now is velocity increases. Object acceleration constant also can. That's still the answer. Okay, so from here we go to the second part, AB. What happened for the AB? Okay, AB. Okay, AB is just talking about the motion. Okay, object move uniformly. No, cannot. Cool. We cannot put object move. Move that means we do know the motion. You must say about the velocity or you say the acceleration. Okay, so the rest give me the acceleration equals 0. Constant velocity. Okay, correct. Dylan also correct. Okay, uniform velocity. Prowess also correct. Okay, so the answer should be object move in zero acceleration. Or you say there's a uniform velocity. Also can, okay. Then we continue to the next part. Okay, how about a B to C? Okay, up again. So B to C actually that's the same lah because the question never give me the number. If they never give me the number, cannot do the calculation. So we just mention there is a velocity increase B to C. You also can say B to C there's a acceleration again. So we just mention velocity increase and acceleration constant also can. Okay, velocity increase. Yes, correct. And the last one, okay, I want to know is the last one, C to D. Okay, so that please answer me, C to D, what is the answer? Okay, the motion for the object from C go to the D. Okay, what should be the answer? Okay, object decelerate. Yeah, correct. Object decelerate. You can say decelerate. Uniform also can because uniform, there's a constant number. Velocity decreases and decelerate. Wow, very fun. Everybody also understand the question already. Okay, now every terror already give me the correct answer. Oh, okay. So from here, I'm going to choose one of the answer. Velocity decreases uniformly. Okay. Okay. If you do want to write about velocity, you can say about the object decelerate. Also can. Okay. So that means the student already understand about the motion graph. Okay, the answer is CD, object decelerate, or you say the velocity decreases. Okay, then we continue to the formative 2.2. Okay, this one, the figure they show about the rock. Here they're taking the 3 minutes. Okay, minutes to walk to the santry shop located 400 meter to the right of her house. Okay, after that, after 1 minute, she buy an ice cream and also walk to the playground. That means they use 1 minute to buy ice cream. Then they start to walk to the playground. It's located 300 meter from the santry shop in 2 minutes. Okay, they walk 2 minutes, go to the playground. Then after that, she sit and also rest on the bench near to the playground for 2 minutes. Sit there for 2 minutes. After that, they're using the shortcut to go back to her house. So Rokia reached her house in 2 minutes. So that means that from the playground straight forward, go back to the house by using 2 minutes. Okay, so from here they ask you, what is the average velocity for the motion of the Rokia? Okay, first one, from the house to the santry shop. Okay, they want to find the average velocity. Okay, average velocity means the average distance, displacement over the average time. So from here, the first one, they want house to the santry shop. So we go to market, this part. Okay, I just want this location. Okay, I just want this location. So anybody can give me the answer. What is the average velocity? Okay, the average velocity means the 400. This one distance should be the 400. Time taken, they say 3 minutes. Okay, help me to convert become 3 times 60. So the final answer, what is the final average velocity from the house to the santry shop? Okay, so anybody can give me the answer? Okay, just calculate only. So we want to find one short part. Okay, 2.22. Lim Si Liang give me 2.22 ms. Okay, meter per second. Okay, so we're going to show, yeah, 2.22 ms negative 1. Okay, correct. Chanel, correct. Okay, T-West also correct. Okay, Prowess also. Prowess, no unit. Okay, must put the unit. Okay, then after that, we go through to the next part. Okay, next part should be the santry shop. Okay, from the santry shop, they want to go to playground. Okay, we need to find the average velocity. Okay, let's see the second slide. Okay, second slide, that means I want this part. From the santry shop, go to the playground. Okay, again, the formula should be the same. Okay, just you convert 300 meter. Okay, go to the playground. They take how long time? They take about 2 minutes. Okay, the 1 minute we never count, because 1 minute is rest. They're waiting. Okay, after that 2 minutes. Okay, now we go to check. 300 over 100, 120. Okay, yeah, correct. The rest, your answer should be correct. 2.5 ms negative 1. Okay, so this one is average the velocity from the santry shop go to the playground. Okay, the last one. Okay, the last one, they say the playground to the house. From the playground they want go to the house, that means should be the shortcut. But the question never give you the displacement. We do know how many. So what we need to do now? Okay, so from here now I want this part. Okay, I want this part. So you want this part, that means you need to find out the displacement first lah. Okay, so fast. The Wash give me the answer 4.17 already. Okay, I go to explain the shortcut first. So the shortcut should be you need to find how many displacement. After that, over total time taken, is it? So from here, how to find this one shortcut? Be using the theorem by Hercules, because this one is a triangle perpendicular. Yes, by Hercules theorem. So we go here to show it, the formula for the bihacurous. So displacement equal 400 square plus 300 square. Then you need to square root. So from here we find it, the shortcut is a 500 meter. Okay, so now I can apply the average velocity from this one question. So the average velocity for the C, for the tree, A3, then should be V equal 500 over 2 minutes, because they said 2 minutes reach the house, is it? So 2 times 60. So the answer is, yeah, correct. Okay, 4.17 times 10 power, 4.17 meter per second. Okay, correct, Travis also correct, Okay, then we go through to the B. B already is this one. Okay, continue. Calculate the rocket average speed. Overall average speed. Okay, important is the speed. Speed, that means we don't care about direction, is it? Speed means overall. So from here, you need to find the overall the overall distance over the overall the time. Okay, some student will ask overall the time. That means the rest one after 1 minute go to buy ice cream then sit at the playground for 2 minutes we need to count or not? The answer yes. Okay, every means we count overall. We don't care you are rest, you are sleep. Important the whole journey you take how long time. Okay, so that means all the distance you plus already, then you need to divide total whole journey. The time taken is how long. Okay, so from here distance we know lah 400, 300, then this one 500. So overall is 1200 meter. Okay, time taken, we need to know the time taken. So you see first one they say 3 minutes. Okay, then they go to buy the ice cream is 1 minute, so total four already. Okay, from the santry shop they go to the playground, they're using 2 minutes, so that means already 6 minutes. Okay, after that they sit and rest at the playground for 2 minutes again, so 6 plus 2 become 8 already. Last one they said they go back to home by using shortcut, also using 2 minutes, so total already is 10 minutes, okay, to go back to the home. So from here we need to show the calculation. Okay, average speed, total distance over total time. Remember, changes become second. Okay, so what is your answer? Come on already. Okay, Divesh, they give me 2 meter per second. Okay, yeah, exactly the answer. 2 meter per second. Okay, so I think you understand about what means of the average velocity. Okay, Winnie. Okay, Winnie, how also correct. Okay, then we go to the next part. Okay, question number four. Question number four got a little bit harder. You need to understand the question because you need to plot the graph. Okay, sketch only. Sketch, that means we no need got the number. Okay, we no need to follow exactly the number because you need to show about the shape. That one we call sketch. Okay, first one, they want to draw the acceleration against the time. Okay, we get the info first. The car driven from rest, okay, u equals 0, accelerate at the 4, acceleration is a 4 for 8 seconds. Okay, first round, the first section, that means from the rest go to the acceleration 4 by using 8 seconds. Okay, second round, the car is driven at constant velocity for 20 seconds. So that means after 8 seconds, now your velocity constant. Constant how long? 20 seconds. Means total already is 28 seconds. So you don't miss about the 8 seconds before. Okay, the 20 must plus back 28 seconds. So that means now the journey already is 28 seconds. After that, brake. Brake is applied. When the brake applied, sure, slow already, is it? Slow already, then we understood sure is a deceleration. Deceleration, understood you need to put negative. So from here, they say the car reduce the velocity at the rate 2 ms negative 2. This one is a acceleration. So when they say apply the brake and also reduce velocity, understood this one you need to put negative. Okay, negative means you already apply the brake. The whole journey you slow down. Okay, this one is the last journey. Finally, stop. Okay, finally you stop. You slow down, then finally you stop. Okay, first round we need to sketch the graph of the AT graph. Okay, we get the info first. This one is the info. Acceleration 4, okay, for 8 seconds. Second round, constant velocity with 20 seconds. The problem is we do know you constant how many. Okay, I do know you constant velocity is how many. I need to find out. Okay, if not, I cannot plot the graph. I do know how many height is it. So from here, last one, they say brake is applied. That means deceleration until stop. So they're using negative 2ms, 2ms negative 2. Okay, let's see the graph. Okay, I already plot it. Then you can see here. Okay, this one is a graph I plot. Okay, acceleration 4ms negative 2 is it? So this one is a 4ms negative 2. Okay, how long? 8 seconds. So I need to count like this one 5, 6, 7, 8. Okay, until here. Then stop. Okay, after that they say constant velocity. Constant velocity means zero acceleration. Zero acceleration, that means you draw the line here lah. Draw the zero here. Okay, from the 8 second until 28. Because they say 20 second, is it? 20 plus 8. You cannot ignore the 8 second. So that means you need to plus 2 8 second. So that means you are until 28 second, you are constant velocity. Means zero acceleration. Okay, after that, the brake is applied. So that means already is a decelerate. Okay, decelerate how many? That is negative 2. So from here, I draw negative 2. Okay, from here, I don't know how to stop. I don't know where to stop. The question never provided. Okay, this one I know they stop at the 44 because I go to find the second question. Teacher, do we need to sketch the graph on the graph paper? Graph paper is more easier to see. Okay, better, Chanel. We just draw inside the graph paper. That means you can see very clear. Okay, better we draw from the top until the bottom. So that means acceleration is the first one, then followed by the VT graph, followed by the last one is the ST graph. Whole graph paper, that means the time should be, the point should be the same. The time taken must be the same. Okay, maybe the y-axis you label by yourself, but the time for the whole AT, VT, ST also is the same. Okay, because the time taken is the same one, is it? Just the changes is the acceleration, velocity, and also displacement. So that means when you draw the whole graph at the top until bottom, you can see what's the difference. Okay, actually I draw whole graph, because the PowerPoint is too small. I cannot put the whole paper. So I go to cut. Okay, this one is the first part. Okay, so from here, I told you already, this one 44. I never do the calculation, but I know 44. Why? Because the velocity. The later one is a VT graph. VT graph we can count. So after you count the VT graph, that means you can draw the acceleration. You stop until 44. Okay, now I want to show you the second one. The second one should be the VT graph. Okay, so we need to understand the question first. Okay, first round they say 4ms negative 2. Then the initial is a 0, is it start from the rest. The time taken is a x second. Okay, final velocity is how many? Okay, we need to know final. Okay, final velocity, you need to plot the graph later because we don't know where to stop. Okay, so from here, we need to find the equation first. Okay, we got A, we got U, we got T. Then they ask about the V. So from here, no displacement. So no displacement, we understood there's a first one equation. So I just go to show V equal U plus AT. So U is nothing, so I put 0. This one is a 4. This one is a 8. So from here, I know the final velocity is 32 ms negative 1. Okay, this one is I find the first round. First round, you say velocity increase it because acceleration until 4. Okay, VT graph, I need to plot. I need to plot the velocity is how many. Then we find the gradient. You find the gradient must exactly 4. Okay, so now we go to find out the velocity already. We need to find the time taken when they stop. Okay, this one is the last part. So just now I told you I get it 44, is it? How I get 44? Now I go to proof. Okay, now I go to find the time for the last part. Okay, the last part acceleration is a negative 2. Okay, finally the car is stopped. So I put 0. Okay, just now you find already 32 is the initial velocity because they say constant until 28 seconds, is it? So 32 is your initial velocity. Okay, last one, they stop. They take how long to stop? They ask about the time. So from here, they never mention about displacement, is it? So which one is no displacement? So no displacement, still the first one, is it? The first equation. So we still apply V equal U plus AT. Okay, now V we do know then the u is 32. Okay, plus, okay, now your acceleration become negative. Then this one is a t. So from here, my answer is 16 seconds. Okay, means after constant velocity, you take 16 seconds to stop. Okay, so that means your total time taken for whole journey is 44 seconds. Okay, the graph is continuous one. You cannot stay, oh, 16, then I stop at the 16. No, you need to plus before that the time taken is how long. So that means before that we prove already 8 seconds. Then after that, they move again, is it? For constant velocity, 20, is it? So 20 plus 8 become 28. Now the last one, I need to stop. I do know what time you go to stop, so I go to calculate. I find 16 seconds. So totally the whole journey is 44 seconds. Okay, now the info I get already. I need to plot the graph. Continue the graph paper. So if I continue the graph paper, should be like this. Okay, so this one is a just now. Okay, the just now, the graph. Okay, AT graph is it? So from here, this one is a VT graph. Okay, you see, VT graph when starting, they say acceleration 4. So that means from the VT graph, sure is a velocity increase. So this one part A should be the constant acceleration. Okay, how many? 4. So I go to the proof. I get 32, is it just now? Okay, so 32 over 8, the answer should be 4. So that means the part A, when you find the gradient, sure there's a 4 ms negative 2. So just now we find already, velocity is how many? There's a 32. So we draw until 32, then we drop. This one is a 8 second. Okay, so from here, after 8 seconds, the constant velocity, how long? 28 until 28. So that means from 32 constant, then you draw the flat one. Constant velocity means zero acceleration. So acceleration becomes zero, nothing here. Okay, until 28 seconds. So I draw until 28. Okay, the time taken, this one is the center, the second graph. Above should be the acceleration graph. So this one paper, actually, I put at the top. Okay, the whole graph paper, we draw 3 graph. So from here, after 28, okay, then we continue to the last part. Last part is a deceleration, is it? So deceleration until 2 ms negative 2. So from here, I need to find the time. Just now we find already, the time is 44 seconds. So until 44 seconds, okay, this one 45. Before that is a 44. So until here. So that means you 32, you just drop. Excuse me. 32, you drop until 44. Then we finish. So this one is a graph for the VT graph. Okay, excuse me. Okay, so from here, hopefully you understand. This one is an AT graph. I want to convert to the VT graph. So from here, first round, you need to find the velocity first. Okay, you find velocity already. Then you know what divide to the 8 second, I will get 4. Sure is 32 lah. So until the last part, I need to stop. The time I need to stop. So I do know the time how many. So that's why you need to find out the time is how many. So just now the calculation, we get 16. So 16 you need to plus the ORI. So become 44. Okay. So this one is a VT graph. Okay. Now we go to the last part. Okay. Last part is more calculation. Okay. Last part, they want displacement against the time. So let's see the info first. Okay, when starting, we go to first, second, and third. Okay, first round, car moving from the rest to acceleration. Okay, teacher, I don't understand how you find 16. Okay, I recall back the 16. Okay, the 16 is here. Okay, Provis, you can see the 16, how to get it. The 16 is the last part. The last part, that means before the stop. Okay, the velocity already is negative 2. Okay, but the initial velocity means already is a constant, is it? Just now we get the answer is a constant. That's a 32. So after that, they say finally the object is stopped. Then the time taken, I need to find. Okay, I need to find the time taken. They take how long? go to brake the car until stop. So from here, I apply the first equation, V equal U plus AT. Okay, so from here, I get 16. So I get 16 already. So the 16, you need to plus the overall, the time taken, they become 44. Okay, understand? Okay, so this one just something you need to think about that. How to find every part. Okay, because now we separate by 3 parts. Okay, first part they accelerate. The center part is a constant variable, a constant velocity, and the last part is a deceleration. Okay, so the time taken we need to find is the last part. Okay, hopefully you understand what I'm talking about that. Okay, so I need to continue for the this one. Okay, okay, the last one it should be the displacement. Okay, the displacement, the first part for the acceleration, U is start from the rest, then the time taken they take 8 seconds. Okay, after that the displacement we don't know. Okay, we need to find displacement. Okay, so from here I need to do the calculation for the displacement for the first part. Okay, so from here I need to using third equation. Okay, remember the third equation, S equals UT plus half AT squared. Okay, UT we can ignore because U is a 0. So UT is nothing lah. So S equal half AT squared. So I put all the thing in. A is a 4. Okay, T squared. T squared, 8 squared becomes 64. So I get the answer is 128. So the first round, the displacement must be 128. Okay, so we remember it, 128. Okay, then we go through to the second part. Second part is velocity, constant. Velocity, they become constant 20 seconds. I calculate the area under the graph of VT graph can you can do like this. Okay, but later you also need to sketch. Okay, can one you can do Xiliang, you can calculate just now the VT graph, you calculate the area under the graph is okay. Okay, but you must know the graph is how to curve. Okay, which part should be curved, which one should be down. Okay, so from here I show the calculation for the second part, constant velocity. Okay, U and V is a 32 constant because initial and final also is the same. Okay, time taken they take 20 seconds. Okay, displacement we don't know. Okay, so from here I show the calculation. Okay, we're still using the second equation, S equal half V plus U multiplied with the T. So from here, I get my displacement is 640 meter. Okay, 640 meter only part 2. Okay, remember the displacement is keep increasing, is it? So this one is a part 2, this one is a part 1, so we need to plus together, is it? So that means now the total displacement is how many? 768. Because later you draw the graph is keep upping. Okay, you cannot drop one. So the graph 128 then continue up again 640. So in the plus 640 now becomes 768 meter. So this one only part 2. Okay, we go to part 3. Part 3 is stop. Okay, this one is a part 3. Okay, the part 3 is we don't know displacement, is it? Because we don't know where they stop. Okay, we just know the final velocity that becomes 0 because you stop already. Okay, they take how long? Just now the velocity find already, is it? The time taken to stop is a 16 second. Then the initial is 32. Okay, after you constant, you want to stop, is it? So this one should be the initial lah. Okay, final you go to stop. Then the time taken you go to stop is a 16 second. Okay, now we do know what's the S. Okay, you want to find the S. Okay, so from here I go to proof. Okay, I'm using the third equation. We're using the second equation. S equal half V plus U multiply with the T, we find the displacement. Okay, so from here we get it. This one is a 32 plus 0. V is a 0. Then the time taken 60. So I get it 256. Okay, my last part displacement is a 256. Okay, overall. overall the displacement is how many? Overall is a 1024 meter. Okay, so I part by part already, I separate already. Okay, now the shape, you need to know the shape. Okay, you want to go back to see what is the VT graph shape. Okay, wait, I got to show this one. Okay, remember velocity increase. So this one, the graph should be up, curve up, not straight line. This one not straight line. From the 0 until 8 seconds, they up until 128 meter. So when you draw the line, you curve a little bit, then up. This one is a straight up. This one is a curve up. Okay, I have been watching this scene to 3 weeks back, and it seemed like having a personal tuition. Thank you, teacher. Okay, so this one is a curve up until this part 128. Okay, after 8 seconds, they become constant velocity, is it? Constant velocity until 28 seconds. So until 28 seconds, I will stop lah for the constant velocity. So constant velocity means flat. For the ST graph should be straight line up. Okay, straight line up. Okay, excuse me. So from here, 1 to 8 ready. You straight forward, you go to up, straight line, constant velocity. Yeah. So straight line, you up until you stop at the 28 second. Then you stop. Okay. The distance is how many? 768. Okay. You just agak-agak lah because here we cannot measure already. So from here, just now you do the calculation. So now becomes 768. Okay. Then we continue again until 44. Then we stop. Is it? Okay, until 44, we go to stop. So this part is a deceleration. Deceleration, how to draw the graph? This one is a curve, but curve down. Okay, just now is curve up. Curve up means you bend, go up. Okay, curve down means you bend, then you come down. This one called curve down. Okay, curve down, you can see the gradient is keep decreasing. Okay, this one is a first gradient, this one second gradient. The gradient already is decreases. So from here where we stop, we until 44 we stop. Okay, how many? 1024. Just now we do the calculation already. So that means you just draw the line from this one 768, you draw the bend until 1024, then you stop. So this one we call it ST graph. Okay, so ST graph, you need to find all the distance, all the distance you need to find out. For the VT graph, you need to find the velocity is how many and also the time taken. Okay, teacher, where to use the curve up and curve down? Curve up is when velocity increase. Curve down means velocity decreases. So you can see here, I separate by 3 parts. First part means this part. Okay, the center one, constant one is this part. And the last one, you can find it, the curve down already. Curve down means the last part, deceleration. Okay, so this one is how we're using curve up and also the curve down. Okay, curve up and curve down, normally we just draw for the displacement time graph. Okay, because they are the first one. Okay, the lowest one. So this one is how you plot the graph. The whole paper you plot together, you can see what's the difference. Okay, you just separate up is the acceleration, then center one is a velocity, and the last one is a displacement. So the time taken should be the same. Okay, the label for a time should be the same. You see, every time a label is the same. 5, 10, 15, 20, is it? This one also same. Just the side, the y-axis you go to change lah. Okay, this one for the velocity, and the bottom one you go to right again for the displacement. Okay, so from here you can see what's the difference. Okay, then we finish the 2.2. Then we need to go the last part. There's a 2.3. We just left 5 minutes. So we continue. This one short only. Okay, what means by free fall? I think everybody know. Free fall is the object just fall because of the gravitational force. Okay. But the teacher isn't the curve graph represent acceleration. Curve graph also can be represented by acceleration. But normally the acceleration graph will never draw the curve. Okay, but the displacement, because displacement is the last one, okay, the very, very lowest one. So when you say something is acceleration, yeah, the displacement is a curve. Okay, but for the velocity is constant, increasing constant. Okay, curve graph is represent acceleration. Yes, correct. Okay, Tivesh should be the same meaning. Okay, but you need to see the curve up or curve down. Curve down sure is a deceleration. Okay, so from here, free fall. Free fall is a motion with the acceleration that due to the gravitational force only. Okay, so this one we call free fall. Something is falling. Okay, falling with some acceleration, but this one only due for the gravitational force. Okay, we're not related for the air resistance. Okay, next one. Okay. Oh, you show the answer already. Okay. The light hollow plastic ball. Okay. The hollow plastic ball means very light already. Okay. Another one, solid steel ball of the same size that released from the cliff. Okay. Of the hill. Okay. Will the both ball will reach to the foothill at the same time? Explain your answer. So for this one situation, they're not exactly the vacuum, is it? Okay, they're still inside the cliff of the hill. Okay, after that, another one, the light hollow plastic. Hollow plastic is very, the very lighter, is it? Lighter, that means they will disturb by the wind. Okay, so from here, the question asked, will both of them will reach at the foothill at the same time? Okay, so from here, we need to say about the perfect one. Okay, the answer is no. The solid steel ball that will reach first compared to the hollow plastic ball. So that means the steel ball come down first, then followed by the hollow plastic. Okay, reason because they due to the presence of air resistance. Okay, we need to explain because of the air resistance affected. Okay, then another one you must say about the reason why presence of the air resistance then the hollow plastic ball are affected. The reason is the steel ball is heavier. Okay, important is a heavier, big heavier, and also the air resistance that will acting after that they will decreases. Okay, if the thing become heavier, air resistance acting on it a bit decreases. But the thing is a lighter, they also will be disturbed, but become more. Okay, because your lighter air resistance easy to blow it. Important they say in the cliff of a hill. Okay, if they say the normal room in the room, maybe you can say they both fall down at the same time. But this one they got something that will affected. Okay, then another one they explained by hollow plastic ball, hollow the empty one. Okay, just like the ping pong. Okay, then after that they say light some more important, the keyword is the light. Okay, so from here we must say light and heavier should be the difference when they just drop because they got air resistant. Okay, then we go to the number 3. An object through vertical. Okay, through vertical something you need to know until maximum height is 5 meter. Okay, the question they ask about velocity of the object when through. That means initial velocity you're using how many. So when something is through upwards, the info A become negative 9.81 because you are opposite direction of the gravity. Okay, V becomes 0 because you until maximum height, your velocity should become 0, 1 because you cannot move up already. Okay, initial we do know. Okay, initial we do know because I do know you're using how many velocity to push the object up. Okay, the displacement I know there's a 5 meter. So from here they want to find U. Okay, from here we don't have the time, is it? No time means we're using the last equation. V square equal U square plus 2AS. So I go to show. Okay, V square is a 0, so nothing. U square I do know. Then plus 2AS. Okay, now I need to find the U. When you find the U, remember go to square root. Okay, I get it. 9.19 meter per second. 10 meter per second for the initial velocity. I go to push the object move up. Okay, now B, the time taken for the object to reach maximum height. Okay, now I need to find the time taken. Okay, they reach to the maximum height. So from here, I need to show about the info first. Okay, I will explain for you why I need to using the U. Okay, normally the question we do want using the calculation we do it, is it? Okay, but this one cannot. We don't have any excuse. You can find the four equation, they also got U1. Okay, every equation they also got initial velocity, so we no choice. Okay, we need to take out just now the U to apply the second question. So from here, others one, you just take one hilang lah. Okay, from here I hilang what? I go to hilang my acceleration already. Okay, depend for yours. Anyone you go to take up. So from here, they want to find the time taken. So from here, U is 9.19, V 0 because you're until maximum height. Then after that, the displacement should be the 5 meter. I need to find the T. So from here, no A. No A should be the second equation. Okay, no acceleration. So from here, I go to apply. S equal half V plus U, then multiply with the time. So from here, I get it. 5 equal half 9.19 multiply the time. Okay, I need to know the object go up until maximum height. The time taken is how long? Okay, so from here, I get it 1.01 second. Okay, 1.01 second, they up until maximum height. Okay, C. The time required for the object to return back. So understood, your up is 1.01, then you return back, sure it's the same, is it? Because you opposite gravity, then you come down, you pull by gravity, should be the same thing. So the answer, we just times 2. We no need to do any calculation. The answer is 2.02 second. You just take 1.01, it's the first round, go up. When it just come down, you go to times 2. So that's the answer. Okay, 2.02. Okay, then we go to the last part, should be the number 4. Okay, number 4 is a tennis ball release. Just now it's 2 upward, is it? Now it's a release. Okay, release vertically from the building, 50 meter. Okay, so from here, we need to take out all the info first. Okay, something drop. A equal 9.81. Pull by gravity. Okay, initial velocity 0. Because you never push anything, you just release. Okay, time taken we do know. Then the displacement should be 50 meter. Okay, so from here, which one equation we need to use to find the time? From here, we don't have V. No V. So no V, which one equation? No V should be the third equation. Third equation is S equal UT plus half AT squared. UT I just ignore. Why I go to ignore the UT? Because there's a 0. Okay, so I just take half AT squared. Okay, half A, I put 9.81. Okay, so I want the answer from the student. Give me the answer for the time taken. Okay, for the ball to reach to the base of the building. Okay, I want your answer. You show me here. Okay, we just left 2 more questions only. So you can do the calculation. Okay, I just wait for your answer. Okay, the time taken for the ball to reach, okay, base of the building. Okay, we got any student can be respond. Okay, respond for me the time taken they reach. Okay, anybody? Many of you disappeared here. Okay. Divesh? Siliang? Can you answer me this question? Time taken. Okay, 3.19 second. Okay, Silang give me 3.19. Okay, so 3.19 second. So we go to proof. Yeah, 3.19. Okay, 3.19 second. When they just through, let the ball to come down. Okay, now it's a B. So you're ready for the B, the answer. Okay, the velocity of the ball just before hit the base of the building. Okay, before hit. So from here, we need to know the info first. Okay, before heat. So we don't want to take the timeline because the time already is a heat, is it? So from here, we still take 9.81. Then the U is a 0. Displacement is a do know. Okay. Yes, the displacement we know. The whole journey is a 50 meter. Okay, but we do know is a velocity. Okay, the velocity before reach. Okay, reach I know lah. Reach already is a 0, is it? But they say before. Okay, so from here, we just want to take the t, okay, because the t just now you find one. Okay, we take all the info they provided. So from here your answer we using the last equation lah, v square equal u square plus 2as. Okay, I want to find should be the v lah. Okay, the velocity before they reach to the ground. Okay, so from here anybody just type your answer. Okay, negative is ignore. Yeah, because we square root we don't have any negative. Okay, we don't have any negative. So from here we just ignore the negative. Okay, we just take the positive one. Okay, after that, hello, I want the unit. Why T-Resh is no unit? Okay, unit lah. So from here the answer is 31.32 ms negative 1. Okay, the negative, actually we got negative. Here is 2 times 9.81, then multiply 50 already is positive. Don't go to square root. Okay, square root another negative we ignore. We take the positive one. Okay, 31.32 for the velocity before they reach to the ground. Okay, last one. The vertical distance passes at the third second. The question mentioned I want third second only. Okay, this one is a 3.193 second, is it? Now I want third second. Until third second, you move how far? Okay, so from here, we still continue with the info. Okay, info for the C, you still 9.81 because you pull by gravity. Okay, initial still U equals 0 because you are released. Okay, time taken now, I want third second. Okay, I just want third second. Then I want to know the vertical distance is how long. Okay, it only until 3 seconds. So from here, which one equation we need to use? Okay, I want to find S. Okay, from here, no V. Okay, no V understood sure is a third equation. Okay, so the third equation like this lah. Ut we just ignore because of 0. So S equal half AT squared. Okay, so from here, student, you just apply. Give me the answer. What is the S? Okay, what is the S we need to know for this one question? Okay, so just read the student answer. You find for me what is the S when there's a third second. Okay, we just wait the student to answer me. Okay, this one should be the last already. Okay, anybody? I want find the S. Okay, 44.145 meter, yeah. Okay, Celia give me the answer already. Okay, the rest. The rest don't know where to go already. Okay, so we go to show Pravis 44.145. Okay, no unit lah. Where's your unit? Okay, so I go to show the calculation. Half 9.81, then square. 3 go to square become 9 already. So the answer is, yeah, 44.145. Okay, this one should be the final answer. Okay, so I find the student, okay, still understand what I'm talking about. Before that, the previous one, the lesson you still can follow. That's why you can do the summative practice. Okay, so today we thank you for your response. We're going to see the next one should be what? Okay, the next one is the next lesson. Next lesson I want to go through is the initial. Okay, the initial. So from here, for the student, you still not yet subscribed, please you go to subscribe my channel. You just type my name only. You just type my name in the YouTube. Okay, after that, they will come out my whole channel video. Then you just click the subscribe. Okay, so just thank you for your watching. So the student will ask me today the code is how, what's the code. So today I already upload the Google Classroom inside of one exercise about the free fall. So that means you can download. Okay, the second one you need to key in the Google form, is it? The Google form for today attendance. Okay, today the code. I go to see what must code first. Forget already. Okay, today the code is a hashtag. Okay, student, you have me to type here. Hashtag motion. MOTION, capital letter, then 2021. Okay, no spacing. Okay, I try to type. Okay, the hashtag you post first one should be the hashtag first. Okay, I'm going to find my hashtag. Hashtag after that, capital letter motion. Okay, after that, straightforward continue 2021. Okay, so this one is a today code. Okay, please don't copy paste. Okay, many of you they copy paste. Copy from here, paste there. After that, wrong already. So go there, Google Form, you need to retype again. Retype again the today the code. After that, then you go to pass up. Okay, so cannot copy paste because copy paste sometime here they got mistake. They got mistake for the spacing. So from here you just type in the Google Form. That means today the attendance you can get it. Okay, so any question for the student, that means you can PM me lah. Okay, for my student, you can PM me to ask about the further maybe the question you don't understand the answer why like this. That means you can PM me. Okay, so our lesson just until here only lah. So the student you hopefully you can mark your exercise. You can check your exercise the answer. Okay, so from here we go to the next page lah. The next page sure is the thank you page lah. Okay, so there's a thank you for your watching. Okay, for the live. Okay, I already take the time is over, is it? The time already is a 9:40. So sorry, Okay, so from here we just thank you for your watching. Okay, so goodbye, bye every student. Okay, Tipika, thank you. Bye.